this is Josh from Leet Dev, where our goal is to explain LeetCode problems as simple and concise as we can. Today, we're going to learn about the valid parentheses problem. According to LeetCode, this problem has actually shown up quite often in the past 6 months with companies like Amazon, Microsoft, Facebook, Apple, Google. So this is a good problem to have in our toolset. These problems are most likely phone interview questions or potentially starter questions with harder follow-up questions. Nonetheless, in this problem, we'll learn an important technique that will hopefully help us solve similar questions in the future. So let's get started. In this problem, we're given a string S containing characters like parentheses, curly braces, and brackets. We have to determine if the input string is valid. An input string is valid if we have open brackets that must be closed by the same type of brackets, parentheses, close parentheses, and our open brackets must be closed in the correct order. Specifically, the newest open brackets are the first one that should be closed. So let's quickly go through the example. Example 1 and 2, we have cases where it works. We have open brackets followed up by closed brackets. Same thing here, parentheses, brackets, and curly braces. Now, example 3 is a case where it doesn't work because we have an open parentheses and a closed bracket. Example 4 is pretty interesting. It does have the proper amounts of open and closing braces. However, it fails the case where we close our newest bracket first. Example 5 is one where it works, where we have an open curly braces, a bracket, and then we close that bracket, and then we close that curly brace. Now let's talk about how we can solve this problem. The key intuition to solving this problem is to realize that we need to close the newest open brackets first. For example, we close first pair of braces first. And then after that, we want to make sure that our second pair of braces was, and that's how we know we have a valid parenthesis. So we need some way to be able to keep track of this ordering as we process through our string. Does this sound like a property of any specific data structure that we know? It does, a stack. A recap, a stack is a data structure that follows a LIFO policy where basically the last item we put in is the first one that we take out. There are two API which takes in O of 1 elements, so maybe add numbers in 3, 2, 1, and then a pop API that takes out the last element that you put in. So the order here would be we would remove 1, 2, then 3 would be our ordering. So now that we know this, let's get back to the problem. The idea for our algorithm is to use a stack to keep track of all of our open brackets. And then whenever we see a closed bracket, such as this, we pop out the last item that we inserted in our stack to see if they match. If it matches, we continue processing our string, otherwise we return false. The runtime of this algorithm is O of n, because we will be processing all elements in our given string, and each of our stack operation is constant time, so that doesn't add any unnecessary overhead. The spacetime of our algorithm will also be O of n, because in the worst case, we will have to store every single one of these elements again inside our stack because they are all open braces. So let's go through a quick detailed example. Here's a more complex string that we need to solve, and we're going to start right in the very beginning. So first, we would check to see if the bracket that we're looking at is an open one, which in this case it is. So we'll add it to our set. And then we'll move to our next one. And we'll check again if it's open. It is, so we continue adding. Note that this is the bottom, and this is the top of our stack. And for our next one, we check in our string, we see that we have a closed parentheses. So what we do is we pop the first element in our stack and see if it's a open parentheses. If it is, then that means our string is still valid. Otherwise, we return false. Luckily for us, it is a open parentheses, so everything's great. So we just pop it out, and then we continue. The next thing we see is that we have a open curly brace. So we just add that into our stack. Then we continue on to our next string value and see that it's a closing curly brace, which means that we need to pop our last value from our stack and see if it matches, which it does. And so we just continue. And then finally we reach our final string value, which is the closed close brackets. We pop the last value in our stack, and we see that it does indeed match, and as a result, we can continue. And then since we reached the end of our string and we see that our set is indeed empty, we know that we had a valid string where every open bracket has a matching closing bracket. That's the high level idea of how we accomplish this. Now let's code it out. All right, let's get started. First thing we need to do, we need to create our stack. We're gonna make a stack of characters specifically. And this is because we'll be traversing through all the chars inside our string. We'll create a char array specifically of our given string, and we're going to make a for each loop through every elements inside our char array. So now that we are iterating through all of our string, the first thing we need to do is we need to check to see if we encounter any open brackets. And when we find it, we would add it into our stack, push it specifically. So in our code here, we would start from the beginning, and then we would continue iterating through each character in our string and adding into our stack. Until we find a close bracket, which in this instance, we'll check to see if they match the last element in our stack. However, the first thing we need to check before we do anything though is if our stack is empty or not. If we encounter a closed bracket while we have no open bracket, which means we have an imbalance already in our string, and we should return false. And at this point, we assume we have a character that can be used. So let's pop it out. At this point, we have popped out our latest character that we put inside our stack, and we need to see if it matches the current index that we are on. And we accomplish this by writing a lot of if statements. So if our current index is a close parentheses, if the value that we removed from our stack is not the open parentheses, that means we don't have a valid string and we return false. And we just do this for the other two types of brackets we have. And this basically will accomplish what we talked about in our detailed walkthrough. Pop this out from our stack, and we see a match. We add the curly braces into our stack. Pop it out again to see that it matches with our closing curly braces. And then finally, we found our last bracket, closing braces, which matches the last element we put in our stack. And as a result, we have a valid string. There is an extra edge case that you have to think about. For example, if we had an extra closing braces in the beginning, our algorithm wouldn't catch this, and we would just be left with a stack with our open braces. So to ensure that we catch for this edge case, when we return our value, we need to check to see if our stack is equal to 0. If it is 0, that means we look through everything in our string and we have a valid string. And if it's not, that means there must be an imbalance in open braces, which we didn't catch in our algorithm. Let's run our code. Oops, I call it s.pop, but it's actually stack.pop. And that's because I accidentally used the wrong braces. These should be open braces, not closed braces. Again, there we go. That's how we have our solution, and that's how we solve the valid parentheses problem. If you like this video, please like and subscribe to get weekly updates. Otherwise, if you have any questions or comments, please leave them in the comments below. Bye, and have a great day.